This is Chapter 5, Lesson 6, Add Linear Expressions. So when I'm adding linear expressions, a blank blank is an algebraic expression in which the variable is raised to the first power. So in those first two blanks, you're going to write linear expression. So a linear expression is an algebraic expression in which the variable is raised to the first power and variables are not multiplied or divided. The table below gives some examples of expressions that are linear and some examples of expressions that are not linear or blank. In that blank, you're going to write non-linear. So let's look at some examples of linear versus non-linear expressions. So linear expression is 5x. 5mn, however, is not a linear expression because I'm multiplying two variables together. Okay. Another example of a linear expression is 3x plus 2. Okay, notice that I have 3 times x, which is fine because there's only one variable. I have a plus sign, which is fine because I'm not multiplying or dividing anything, and 2. So this is a linear expression. 3x cubed plus 2 is not a linear expression because x cubed, that's raised to a power. Another example of a linear expression is x minus 7. Again, I can have a subtraction sign here, and that's fine. My x and my 7, I'm not multiplying them by anything else. It's just x minus 7. X to the 4th minus 7, though, is not a nonlinear expression because x to the 4th is raised to a power. So you can add linear expressions with or without models. Sometimes you will need to use zero pairs. So let's take a look at an example. So my first example says add 2x minus 3 and negative x plus 4. Okay. So I have a bunch of different colors here. So I'm going to have one color to represent my positive x's, one to represent my negative x's, one to represent my negative 1's, and one to represent my positive 1's. Okay, so I have a couple different colors. So when I have a model, I'm going to model 2x minus 3. So I have 2 x's, 3 negative 1's. Okay, so that's my first model, right? I have 2 x's minus 3. And then for my second, I have a negative x plus 4. So that's the model for that for those two linear expressions. Okay. Now I want to add them together. So I can take some zero pairs. And basically what a zero pair is I can take things and I can cancel them out. So for example, I can take one positive x and one negative x, right? And they cancel each other out. They go away. Then I can take 3 negative x's, or 3 negative 1's, and 3 positive 1's, and they cancel out because negative 1 plus 1 is 0, negative 1 plus 1 is 0, negative 1 plus 1 is 0. So the only things that I'm left with are a positive x and a positive 1, which is how I get my expression x plus 1. So I combined all my tiles, then removed all zero pairs, and I write a linear expression for the remaining tiles. So 2x minus 3 plus negative x plus 4 equals x plus 1. All right, let's try finding 5 times the quantity x minus 4 plus the quantity 2x minus 7. So the first thing I want to do is actually use the distributive property. When I do that, I get 5 times x minus 5 times 4, which gives me 5x minus 20. So this is still a linear expression. Okay. And then 2x minus 7. So I'm going to look at what I have together. I can arrange the terms in columns just like you would when you're adding or subtracting regular numbers. So when I do that, I have negative 20 plus a negative 7. Well, negative 20 plus a negative 7 is negative 27. And then I have 5x plus 2x, which gives me 7x. So my linear equation is 7x minus 27. So 5 times the quantity x minus 4 plus the quantity 2x minus 7 equals 7x minus 27. All right, there are a couple of try-it problems on this page. I want you to go ahead, pause the video, and try them out, and when you're done, we will go over the answers together. All right, now that you've had a chance to look over the try-it problems, let's go over the answers together. Number 1 says find the quantity x minus 1 plus the quantity 2x plus 3. Use models if needed. All right, so I'm going to come over here and I'm going to use models for this one. You don't have to use models if you don't want to, but I recommend if you feel like you're a little bit uncomfortable with adding linear expressions, models is a great way to go. So my equation is x minus 1 plus 2x plus 3. Okay. I'm going to assign a color to each one of these. Any positive x's are going to be this turquoise color. Negatives are going to be negative or orange. And my positive ones are going to be purple. Okay? So I have 3 colors. So I'm going to draw each one of these as a model. So there's x. And there's a minus 1. Okay. Oops. Wrong color. Should be this color. Okay, and then this one is x, because there's 2 of them. And then plus 3. So it's plus 1, plus 1, plus 1. Okay. Now I'm going to look for 0 pairs. Okay. So I have this negative, I don't have any negative x's, so I can't do any 0 pairs with them, but I have a negative 1 and a positive 1 that can cancel each other out. Okay. Now I'm left with 3 x's and 2 1s. So my expression is going to be 3x plus 2. Okay. My second try it out problem says find 6 times the quantity x plus 7 plus x plus 3. Use models if needed. So the first thing that we want to do, after I rewrite this expression, okay, is use the distributive property. So I'm going to distribute 6 to the x and to the 7. This gives me 6x plus 42. 6 times x is 6x. 6 times 7 is 42. Plus x plus 3. Now you can draw models if you want. You're going to be drawing squares for a little bit because there's 42 of them. Or you can line them up. I'm going to go ahead and line these up. So I have 6 plus 42 plus x plus 3. Okay. Now I'm going to add them just like I would a normal addition problem. 42 plus positive 3 gives me a positive 45. And 6x plus 1x, because remember there's an imaginary 1 here, gives me 7x. So my final expression is 7x plus 45. My final try it out problem on this page is find 12x plus 19 plus 2 times the quantity x minus 10. Use models if needed. All right, so the first thing that I want to do is I want to distribute this 2. My first expression stays the same. 2 times x gives me 2x, and 2 times negative 10 gives me a negative 20. Now, again, you can draw a model if you would like to, or you can set them up like a regular addition problem. Okay. When I do this, I have 19 plus negative 20, which gives me a negative 1. And then I have 12x plus 2x, which gives me 14x. So my linear expression is 14x minus 1. And that is my final answer. That is the end of lesson 6.